Hello, my name is Alejandro Tejada and welcome to ME340 training. In this video we will work with the Haas CNC Lathe. Before we start, let me give you some tips, safety tips. Always work with when you start to run the machine, close the door and locate the place of this button. This is the emergency button. So if you see if the machine is doing something wrong, press the machine immediately. Okay. In this video, we will learn how to set tool offset and how to program in the BPS. The BPS is Virtual Programming System, okay, that to generate G-code. The main components of the machine are the chuck, the turret, and the panel of control. Okay. So let's start to loading the workpiece in the chuck. To do that, we need to load the workpiece in the chuck and then tighten securely. Okay. So before we start, this is the ring that we will do. This is a thread and ring. And look at the OD diameter, the ID diameter, and the length, the steps of the thread. So we'll start with the tool offsets. Let me start with tool number 1. This is the tool number 1. So I will move tool number 1 to close to the workpiece, okay? So I have to close the doors, press handle jog, and move the axis. We have Z axis, that is this way, Z minus to the chuck, and C plus to the other side. Then we have X minus is inside of the machine, this way. And the other to the door is X plus in this way. So I will move the tool number 1 close to the workpiece. Let me check this way. When I am close to the workpiece, and I will use a piece of paper, so I need to scratch the piece of paper with the tool tip of the insert. Let me do that. I will decrease the steps, and I will do. Then I move only X axis. So right now, as you see, the tool tip is scratching the piece of paper, okay? So after that, I will press offsets, go to the first line. The first column is tool offsets, highlight number 1, to relocation is 1, then tool type, we press. For this tool, I will do OD turn. Press. Now, I need to put the value for the X geometry. So I press X diameter measure. Then pop up this message that says that I need to put the diameter of the rod. So I will use a caliper to measure that. So it's 1 inch. So I have to put 1 point enter. Then I need to set up Z geometry. So for do that, I need to move again the turret. Let me move in Z direction, press handle job. Not I will need to go inside of the machine and then come back again to this phase of the rod. Decrease the steps. Again, the same process. I need to scratch the paper with the tool tip, okay? So, and then press again offsets. In the column of C geometry, press C face measure, and that's it. After that, I need to go to the next column, is radius geometry. For this tool, I have to put the value is 0.0157, and the last step is to put the tip direction. We have the movement for the tool for this process will be -x and z minus, so the number traces we did. The first tool is now set up. Now the next step is to move to a safe place the turret. Close the door because I will need to change of tool, tool number 2. So to do that, press MDI, G2 to record. So I am changing of tool. Now we are in the tool number 2. This is the threading tool. So I will do the same process that I did first. So press handle job. We need to jog the turret until the workpiece. When we are close, decrease the steps. Use a piece of paper and scratch. Okay. Now in that position, now the insert is scratching the paper, and I will set up the offsets. Again, press offset, go to the second row, to relocation number 2, it's okay. In the third column, I will put OD thread. X geometry is we need to press X diameter and put the same value that we put in the previous steps. Now C geometry, I need to move again the turret. Okay. Go inside of the machine. Now in this insert, you have to touch the rod in Z axis. Let me decrease the steps. Move slowly until the insert trap the paper, okay? We can set up Z axis. So again, press offsets, go to Z geometry and press Z face measure. The radius geometry right now is set up. It's 0.003 for this insert. And the tip direction is the same that the turning is -x and -z. Okay. Now the next tool. Press handle job. Move the turret to a safety place. Close the doors and press MDI T3 turret forward. The machine will change the next tool. Open the door. Now we are in the tool number 3. It's a parting off tool. So we need to do the same process. Again, hand job, move the parting tool close to the workpiece. Very close. When you are very close, change the step increment. Use a piece of paper and scratch the paper with the insert. Okay, that way. Again, press offset. This is the tool number 3. To relocation number 3. The process will be part off, press enter. In X geometry, press X diameter measure. It's the same as the previous, 1 inch. Now Z geometry, so press jog. I will move in Z direction. I will go inside of the machine, and then I need to, the face of the tool touch the face of the workpiece. Decrease the steps. Now it's touching, the tool is scratching the paper, so again press offsets. C geometry, press C face measure. Then the next column is for the radius geometry. So for this tool, the radius geometry is 0.00A. That's it. And the tip duration only, this is a parting off tool, so only will be -X, so it's okay. Minus X, H. Okay. The next tool. So move the tool again, increase the increment. We need to change the last tool, it's a boring bar. So press MDI T4 to refer one. Okay. So we have the boring bar, but before we start with the boring bar, to set up the boring bar, we need to do a hole in the machine, in the workpiece. So I will use the boring bar as a driller. Okay, so I will set that as a driller first, and then as a boring bar. So I need to move the boring bar close to the workpiece. So I am trying to align the axis between the workpiece and the tool. And that way, I will need to touch. Okay. So I will go to offsets again. So I will use the tool offset number 5. The tool relocation is number 4. I will drill with this tool. The X diameter is 0 because it's drilling, so it's supposed that the machine thinks that this tool is in the center of the machine. And press C face measurement for the C geometry. Okay? So I will do a hole right now. I will use BPS to do the hole. So I will go, to do that, I need to press MDI plus edit. Go to BPS operation. In this case, it's in another process, so I need to come back to the first screen. This is the BPS screen, so go. I will do drill tab, this is the pad, and drilling, the second option. Now, I have to put the values for each variable. So we have tool number 4 is okay, tool of the number 5, in this case. Then work offset is okay. I will work with 300 RPM. Z rapid approach, I will work with 0.5. Airplane, it's 0.1 is okay. Drilling cycle, I will use 83, this PEG drill. Flux column, yes, I will use flux column. Feed rate 0.005. And the depth of cut will be 0.6. PEG increment 0.06. I will retract to home. No, I will use a new position. In X direction, 6 inches. And for the Z-axis, I will use 8 inches. And the final M code, I will put 30 to finish the code. After that, I need to generate the code pressing F4, and I will select output to the MDI. Now my G code was generated, and this is in this part of the panel. You can see this is the drill operation. So I will close the door to run this process. I will decrease the rapid, so you see, and I press cycle start and start the machine to do the hole. So we have the hole done, so we need to set up offset for the boring bar. So we need to move the turret close to the workpiece. We need to go inside of the hole. Beware in this part. Now decrease the increments. Move X axis until you touch the inner wall of the workpiece. Okay, so you can move the choke to see if the tip is scratching the inner wall of the hole, and that is okay. So after that, you press again offsets. I will use tool offset number 4 to relocation number 4. The process will be ID turn. Now we need to measure X geometry, so we need to know what is the diameter of the hole. So I will move first the turret. I need a space to use the caliper again. 0.41. So we put again X diameter and put the value 0.4125 inches. And that is the. Then the next is Z geometry. So I need to move and touch the face, the Z face of the tool, of the workpiece, sorry. Use the piece of paper to scratch. Okay, so we have that way. Offsets. Z geometry, put Z face measure, and that's it. Then the next step is the radius geometry. The radius geometry is 0.0157. That is okay. And the tip vibration is plus X and C minus. Okay. So number 2 is okay. Okay. Move to a safe place the workpiece. Sorry, the turret. And now I will start with the BPS. So to enter to the BPS screen, press MDI, edit. This is in the drill, so I need to come back to the initial screen. This is the initial screen. So this is the tool BPS. Press enter. The first operation will be OD turn. So go to OD turn, enter. And the final process is OD turn again. This is the path to have. So I need to enter all the values for each parameter. For the OD turn, the total number will be the 1. We need to change that. Tool offer number 1 is okay. Work office 54 is okay. We are working with a tool holder like the image A. 3 is clockwise, so I will choose it. The maximum RPM will be 600. The surface speed 150. The rapid approach I will use 2. X rapid approach 0.1. I will use a coolant. The OD diameter was 1 inch. The finished diameter is 0.96. The Z cut length is 0.55. Fillet radius 0. The depth of cup 0.02. The feed rate 0.008. It's okay. We don't need a finish pass, so I will select 71 without finish pass. Finish stock 0. C finish stock 0. Tool change exposition to 6 inches. And tool change position Z to 8 inches. Enter. And code number 1 is okay. After that, press F4 to generate the code, the G code, and press output to MDI. Enter. So we have the code here. So the next step is create a program. So press letter O and the Alt key. This is a pop-up where you can write your program number. So I will choose a random number, for example 0, 1, 2, 3. And I need to save So now there is a program. So I will select that program, press the button list of program, and check where is your program. We can see it here. This is 0123. It's the name of the number of our program. Press enter and then select the program. So we have the program in our screen. The next step is to programming the next tool. The next tool. Go to the first screen. Press BPS. OD turn and OD thread. The same way, we need to put the values in the machine. So the threading tool is in the tool number 2. So we put 2 and there. We're off at 54 is okay. Coolant 8 is okay. Threading direction, we want to go right hand thread. Thread 4 inch we will change 12 4 inch. The OD diameter will be 0.96. We don't need to change the minor diameter because the machine calculates the minor diameter according with the major diameter. The C rapid approach, I need to use a small value. We want to use 0.2. X rapid approach 0.1. The first pass will be, we will use 0.02. The same depth, the depth of cup. Flanning flits 59, it's okay, no change that. Thread length 0.5. Chamfer retract 23 is okay. Thread taper 0 is a flat thread. Surface speed 150. Spindle RPM 700 RPM. The start point 0 is okay. Refract to home. X. No tool shank position, the same values that the previous step. 0 inch for X position. And A for the Z position. Now you have to finish to put all the values. Press F4 to generate the G code. We need to copy this new G code in the program. So select Insert to Clipboard. You are in your program in this A. So you have to go to the final line of your program. Press Page Down. And here in this point, you have to paste the new code. So press F4 to paste. And then press Memory to save and load. The next process is ID turn. So come back to BPS again, press MDI edit. Go to the screen. Come back to the initial BPS screen. This is the path, BPS. Go to ID turn. Then go to edit turn again. Select tool number 4. Tool offer number 4 is okay. Word offer is 54, don't change that. Maximum RPM is 400. Surface speed 150. Rapid approach, I choose a small value because we don't have too much space inside of the hole. Also, X rapid approach is 0.005. Through coolant 8 is okay, it's active coolant. The hole diameter, measure again if you don't remember, 74. The finished diameter will be 0.8. Cone length Depth of cup will be 0.5. Filler radius 0, depth of cup 0.0262. Fill rate 0.02. Finish pass without finish pass, so we select 71. Finish stock 0, C finish stock 0. Retractor home, no, so we put the same values to the previous step, 0.6 for X position and 8 for Z position. To write all the values, press F4 to generate the G code and insert to clipboard. Enter. Go down to the final line of your program and paste with F4 the new G code. So you have a new process, is ID turn. Okay. Name, press memory to save. And the final step is to the padding off operation. So press MDI, edit, go down home, come back to the initial VPS panel, and then go to OD turn, and then part off. The part off, the total number is 3 for this tool. Tool offset number 3 also. Board offset number 54. The insert width is 0.11a. It's okay. No need to change. So 97 is the spindle RPM. The spindle RPM type, o sea, it's clockwise. Spindle RPM is 500. Z rapid approach, I will use 0.2. X rapid approach 0.1. Fluke column 8. Part catcher doesn't matter because we don't have, but I will use 37. OD diameter is 1 inch. The finest diameter I will use 0.7. The cut, C cut length 0.5. Feed rate 0.004. Peg distance 0.05. And the same step for to tool chain position. We will use the same values. 6 for X position and 8 inches for the Z position. After that, I will use the M code. I will use 30 to finish all the program. Again, I can generate the G code, press F4, insert to clipboard, enter, go down to the last line of your code, and press F4 to paste. You have a new line with a new cycle of operation. Press memory and save. Now I am ready to run the operation, the program. So I will close a little bit the doors. Then I will press coolant and align manually the coolant to the work with the tools. Let me change to the tool red. Press MDI T1 to roll forward. Now I will align again the coolant. Press coolant. I will run the program. That's it. Ring. This is the final, the thread-on ring. And we are done.